Hello, this is Dr. Mode and welcome to chemistry class today. We are continuing the chapter on acids and bases, and this final section is called Neutralization. Our scripture from today comes from Psalm chapter 105 verses 1 through 3. O give thanks to the Lord, call upon his name, make known his deeds among the peoples, sing to him, sing praises to him, tell of all his wondrous works, glory in his holy name. Let the hearts of those who seek the Lord rejoice. So the big idea for chapter 18 is acids and bases can be defined in terms of hydrogen ions and hydroxide ions, or in terms of electron pairs. As you can see, we finished the first 3 sections and we are starting section 4 in this lesson. The essential questions from this section are: what do chemical equations of neutralization reactions look like? How are neutralization reactions used in acid-base titrations? How do the properties of buffered and unbuffered solutions compare? So a neutralization reaction is a reaction in which an acid and a base in aqueous solution react to produce a salt and water. So here we have an example. We have magnesium hydroxide reacting with hydrochloric acid to form magnesium chloride and water. So the magnesium hydroxide is our base, the hydrochloric acid is our acid, and then it produces a salt, the magnesium chloride, and it produces water. So if we were to write out the ions for this equation, it would look like this. But certain ions appear on both sides, so they're called spectator ions. So what we can do is we can cancel those out. We've canceled out the magnesium on both sides and the chlorides on both sides. And what we're left with is basically hydroxide reacting with the hydrogen ion to produce water. So a titration is a method for determining the concentration of a solution by reacting a known volume of that solution with a solution of known concentration. So for example, we could have an acid that we don't know its concentration, and we could have a base that we do know its concentration. Well, what we could do is react those two together, and by paying attention to the volumes, we can determine the concentration of the unknown acid. So the two graphs below, let's look at the left one first. Here what we have is HCl reacting with NaOH. So what we have here is a certain volume of NaOH that's added, and you can see that that's going across the bottom. So the pH is on the vertical axis. So you can see that initially this is a very acidic solution, and as we add the NaOH to the hydrochloric acid, what we're doing is we're neutralizing some of that acid, and we get to a point where it's completely neutral, okay? And that's marked on the graph with this line coming off the center called the equivalence point. And the way in a titration that we can tell that the reaction is over with is by using something called an indicator. And this shows bromethymol blue. Bromethymol blue, it shows a little color change here. Initially it's clear, but it turns a bluish green color when it gets to that equivalence point. So it can be used to determine when the reaction is over with, or when you've added the right amount of NaOH to cancel out all of the HCl. So on the next plot on the right, we have the same type of thing going on. The only difference is there's a different indicator that's used. This time it's called phenolphthalein. Phenolphthalein, instead of going from clear blue, it goes from clear to a pink color. So what we can do is when we get that steady pink color, we can tell we've added enough NaOH to react with, in this plot, the formic acid, HCOOH is formic acid. And when those have completely reacted with one another, we've got to this equivalence point, and we'll have a steady pink color that occurs at that point. Chemical dyes whose color are affected by acidic and basic solutions are called acid-base indicators. So this plot right here is it contains a lot of different acid-base indicators, and it shows you what colors they change. So you can see at the very top of this is pH. We've got pH going from 0, the acidic, the very acidic condition, up to 14, the very basic condition. And you can see that when you add some of these indicators to an acid-base reaction, they will change color in the range that you see here and tell you when the reaction has gone through that pH range. So we've talked about a couple of these. Phenolphthalein is the 4th from the bottom. Bromethymol blue is the 6th from the bottom. So you can see those two on here. The one at the very bottom is kind of interesting. It's called the universal indicator, and it changes to several different colors throughout most of the pH range. So I've told you what a titration is, but these 3 pictures show what a titration would look like. So what we have here is this shows the burette at the top contains a standard solution of NaOH. So that means it's a solution that you know its concentration, and in the bottom there is 25 milliliters of formic acid, and it's got a little phenolphthalein indicator in it. So what we're going to do is we're going to add that NaOH until we completely neutralize the acid that's in the flask at the bottom. So as you add that, what you're going to see is a little bit of pink color show up, but if you swirl that flask, what happens is that pink color goes away because you're not quite at the endpoint yet. The reason the pink shows up is because locally at where the base hits that, it becomes more basic in that local region, but as you swirl it and mix it up, that averages out, and it's not quite to where it needs to be yet. So you can see on the far right picture, that's where you get to the end point. It's marked by a color that is persistent, that stays even if you swirl it around. Once that color is achieved and is persistent, then you know that you're at that neutralization point.